All right, synthetic division. This is day 4. This is the last video for this unit, which means we have a test coming up. Okay, so pay really close attention to this. So the process for dividing a polynomial with a linear expression, so it's x minus a, it must be in standard form, blah, 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 is synthetic division. Okay? If you divide a polynomial p of x of degree n is greater than or equal to 1, then the remainder is p of a. That's the remainder theorem. I'll get more into that so it'll make more sense. So let's just look at this first example. So we have to write the polynomial in standard form, including zeros for the missing powers of x. So I want to do that real quick. Let me go back. So if we look at this right here, we have an x cubed, we have an x, and we have a constant, but we don't have an x squared. So we write that in standard form. That's going to be x cubed plus 0x squared minus 57x plus 56. Write that down because it's going to go away in a second because I haven't figured out how to make it stay. But write that down. So in standard form, since we don't have an x squared, we have to write that 0 in for there. Okay? So let's go to this. So you draw this L-shaped thing. It's kind of just like an upside down division. And then we're going to put our terms in there. We have 1, 0 for the x squared term, negative 57, and then 56. So you just put the coefficients for each of those. And then on the outside, it's the opposite of whatever that is. So that's a negative 7, so this is a positive 7 on the outside. Okay? The first step to this is to bring down the first number. You just bring it down, and it's a 1. And then you multiply. So you do 1 times 7, which is 7. And then you add this. 0 times 7, or 0 plus 7 is 7. Then you multiply. 7 times 7 is 49. Then you add. Negative 57 plus 49 is negative 8. Negative 8 times 7 is negative 56. You add those, you're left with 0. So now we have these numbers. We have some coefficients here. We have to figure out how to write these into some sort of polynomial. We started with a polynomial of degree 3. So we're going to go down 1, which means this is going to be degree 2, which means our first term is going to be squared. So that's going to be x squared plus 7x minus 8. You could put a 1 here if you want to. You don't have to though. Okay, so that's x squared plus 7x minus 8. And we don't have a remainder because our last number was 0. So that's the final answer on that one. And you're done. It's a lot quicker than regular division. The only thing though, you can only do this sort of division when this number right here is only an x. So it could be x plus 4, or I wouldn't say x if it's a variable. It could be n minus 400, or z plus 90, or q minus 41. I don't know, just weird numbers. But this, they just have to have this 1 right there. It can only be a variable and then a number. It can't be like 2x plus 4. Or it can't be x squared minus 4x minus 9. It can't be anything like that. It just has to have this 1 variable right there. Okay? So let's go and let's just do some more examples. So I'm going to draw my L again, and I'm going to put my numbers in there. So for this one, it's 1, negative 5, negative 46, and 11. Because I didn't have any variables missing. Then opposite of this on the outside, so it's negative 5 on the outside. Okay, first step, bring down the 1. So 1 times negative 5 is negative 5. You add those. Negative 5 plus negative 5 is negative 10. Multiply. Negative 10 times negative 5 is 50. You add those. You get 4. 4 times negative 5 is negative 20. 11 minus 20 is negative 9. Now this again was degree 3. So this one is going to be degree 2. It's going to be a quadratic. And then the negative 9 is our remainder. The last number is always the remainder. So this is going to be v squared minus 10v plus 4, then minus 9 over v plus 5. So it's always over whatever you divided by. I know it looks like we divided by negative 5, but we actually divided by v plus 5. So this is your final answer there. Okay. Let's do example A. So here we're going to draw our L again. We have 1, 8, and then we don't have a b term, so I have to put 0 in for that b term, then -8. And on the outside, we have -8 because it's the opposite of +8. Okay, bring down the 1. 1 times -8 is -8. 8 minus 8 is 0. 0 times -8 is 0. 0 plus 0 is 0. 0 times -8 is 0. So -8 plus 0 is -8. Okay? Again, this one was degree 3, so I'm going to drop it down to degree 2. So that's going to be 1b squared plus 0b plus 0 minus 8 over b plus 8. Those 0b's and the zeros can just go away, and you're left with b squared minus 8 over b plus 8. Because this, I don't know where those subtraction signs went. That should be a negative. That should be a negative, which it was on the page before. So I just forgot. Good. Okay. So let's go to this one. So we just have to determine if we can use synthetic or if we have to use long division. On this first one, you can use synthetic division because it's just dividing by the x plus 6. The second one, you have to use long division because it's dividing by this x squared plus 5x plus 5, which is not just an x, so you have to use long division. C, you also have to use long division because it's dividing by the 3x minus 2. D, you can use synthetic division, you just have to change that to x plus 2. Okay? Last little thing, so this is the remainder theorem. So we have to find p of -4 given p of x equals x to the 5th minus 3x to the 4th minus 28x cubed plus 5x minus, or plus 20. So if we're finding p of -4, I'm just going to plug -4 in for all my x's. And I want you to pull out your calculator if you have it, and I want, or not my calculator, your calculator, pull it out, plug this part in, the right side of this equation, exactly how it looks. Don't try and do it all fancy, just plug it in exactly how that looks. And you should get 0. Since you got 0, that means that the remainder is 0, which means that x plus 4 is a factor of that. Okay? Before I tell you to take the quiz, if we were to plug in p of 4, that'd be 4 to the 5th minus 3 times 4 to the 4th, blah, 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 blah. Plug that in, you would get some number. I don't know what that number is, but I do know you get a number. That means that p minus 4, because I'm plugging in positive 4, is not a factor. Okay, so if you get 0 out, it's a factor. If you don't get 0 out, it is not a factor. Okay, that's just the remainder theorem. So this tells you that when I plug in -4, the remainder is 0. When I plug in positive 4, the remainder is some number, which means it's not a factor. Okay? And now you can take the quiz, and I'll see you guys tomorrow.